Ivan Shamatov.
Hello, my name is Ivan Shamatov, and I'm really glad to be here, and I thank organizers for inviting me. That's mean a lot for me. So that's almost the end of the day, and I guess you're all tired, so we're not going to talk about anything fancy and like hardcore, just money. So a couple of words about myself. I'm a community lead in St. Petersburg, Russia. And I know that's hard, but I invite all of you to come, please. We organize meetups, conferences, and so on. And I also work at Cybercharger. So one more thing, like this summer, this summer I was the first time in my life in Italy, Rome, and I was really impressed by masterpieces created by masters of Renaissance epoch and the 11th century. And you maybe heard some of the names of these masters, like Leonardo da Vinci, Michelangelo, Raphael, and Fibonacci. Yeah, I've already heard the correct name. So that's a quick test for you. If you're a real developer, a Ruby developer, please lift up your hand if you ever implemented a Fibonacci sequence algorithm on your interview job. Not all of you? Okay, most of us. So yeah, but Fibonacci is actually well known in other world than Ruby. Not for his sequence, but this book, the Liber Abaci, where he first introduced Hindu-Arabic notation for Western world. And before that, just for you to understand, they used Roman notation, and there were no way to represent fractions of something, like you cannot write 1/2 or 1/3 part like in Roman notation. There were no such way to represent zero, like nothing. So he first started to use zero for that. And he started to use negative numbers and showed that that's quite useful to use negative numbers to represent depths. And the way how he explained his examples were by application in bookkeeping, calculation money. He started to use proportions to explain how to convert weights, because each region of Roman Empire had different measurements and system like for weights. And that's why he so actually should be famous. So please. Going back to our days. So the way how we can represent money is usually a cortege of some amount and the currency, right? But because in Ruby we don't have such thing like a cortege, we usually make a struct. And that, can you see it? Yeah, okay. And that's a simple way to represent money. So you are creating a struct of amount and currency, and it's useless at all, because we cannot do any kind of operations with this struct. We have to implement them. So let's think what kind of operations we can do with money. And the obvious answer would be like making money, saving money, sharing money, and losing money, of course. Okay, just kidding. What I'm talking about is math operations. For example, plus. I've extended my money struct with the method plus. I added two type check-ins. Like, for example, you cannot sum money with apples, otherwise you know how to convert apple into money. So you can actually exchange apples to money and then some amounts. And I also added a check for currency mismatch, because we cannot actually, well, that's obvious. And to be a good programmer, in best practices, we are not mutating our values, but creating a new struct with the correct amount and the currency. So let's use it. We are creating 10 cents and 20 cents, and we are summarizing them. And guess what? We are starting to make some money. Well, does anyone know what's wrong with this implementation?
You can't use floats for money. You need to use integers.
Yeah, okay. Please don't use floats. And here is a snippet for it, and that's quite fun when you have an amount which is more than you expected, but not so fun when you have less than you expected. And here is the website. The website that explains what happens actually and how this feature implemented in all of the programming languages you possibly know. So please come, you can check how different languages behave. So rule number 1, never use floats to make money calculations. This can be easily fixed with just drop in with big decimals. Actually, it's not fixing the problem, but the amount of precision is so high that you possibly won't get at the point when you really need that amount of digits after decimal point. So next piece of code. I'm sorry for that. That's the biggest snippet I have in a presentation. I will read it once, and after that, we will leave this topic. Okay? So I introduced new types and dry types, and I have an amount of params, like types params decimal. Because Ruby kernel library cannot curse float into decimal, so that's why we use params decimal. And why floats? I still want to use floats because they're quite easy to write. Like, you don't have to wrap your number with the big decimal square brackets thing. And I also constrained it to be greater than 0, which is obvious. And the second thing, I created a type of currency where I just limited the list of possible values for currency symbols to be USD, BTC, Chinese, something, I don't remember, hryvnias and euros. And our implementation in Ruby is not very different from what we had. So we just added an attribute of amount in the currency with the correct new types. So let's try to use them. And if you can see, the behavior is exactly the way we expected it to be. So there is a moment when you start to think that you really need to save your value in database or restore it from database. So rule number 2, please use a correct scale and precision in your database to retrieve and save values of the money. I've heard that someone said that we should use integers, and that's exactly the most common approach for whole word to save like the smallest fraction that we have. For example, for US dollars, it will be cents, kopecks for hryvnias, and pennies, and so on. Okay, but it won't work for cryptocurrencies at all, when the fraction is changing all the time. And possibly you don't care about something that's less than a cent, but there are some countries where they have currency where it means a lot. So what if we just round by 4 digits after decimal point? You see that like when Bitcoin was just $100, that doesn't nobody cares about it, but it will give you twice more money right now. And we had the situation when we had all the amounts with the fractional, like thousands, like 4 digits after decimal point, and when Bitcoin grew up and up to $20,000, and we rounded by at least $20. That's a lot, and that's very profitable for a short time, but not really profitable, and does not look like customer success for a long time. So what about rounding? How should we round? Like, should we round up or should we round down? And the answer is yes, of course. So let's take a look at this example. This example is about like converting $10 into amount in Bitcoin, and we know that this will also include transaction fee. We also want our service to be profitable, and we take some interest for converting money. And we also have a referral system in our project, and that's why we have to also pay for referral. So how should we round these values? And the way how we can calculate some BTC, the thing that we will pay for our customer, is we are taking whole amount in BTC, which we calculate by proportion, which is obvious. And we know that transaction fee is a fixed number, and we actually cannot affect it. I mean, like in this concrete example, it is fixed. Yeah, of course, customer can change it, but it's still fixed. And we want our referral to get his money by, but we don't want to pay him more than we actually need to. So we obviously round it down. Why not? And our interest, why we should give away some money we actually want to have. So we round it up. And yeah, see, there are 2 types of rounding at that exact example. So another example, we are exchanging product in some kind of, for price in rubles. And it consists of delivery, supplier price, and the amount we pay, like payment gateway, and actually our taxes. And how would we calculate our net profit for this exchange? And for example, in Russia, they don't care about kopecks. They force you to convert it to whole numbers. So they ask you to round it up and round by whole numbers. So that's the 3rd way of rounding. And it's exactly the business logic, not the thing that you can like put every time you see numbers, just rounding them down. Every time you have them or round them up. So supplier's price is fixed, delivery price is fixed, and the payment gateway wants its 2.5%. But we are not going to run them at all, because we don't know how to do that. Like, we actually can't pay them less than we really need to. but we don't want to pay them more. So according to your agreement with the payment gateway, you can accumulate all the prices for like a long period, for example, 1 month, and save all of the numbers that you have to pay with with the biggest precision you can actually in your system, most valuable, okay? And round them once per month. And so row number 3, please use rounding wisely. And there were stories about how people do rounding, opening accounts in bank and like making money, like 3 rubles per month, just because of errors in the system. So 3 rubles is a lot. The last name at this talk is Luca Pacioli. Luca Pacioli is a monk from Italy, of course, and he is famous as the father of accounting, and he wrote this book, which is Summa de Arithmetical Geometry Proportioni and Proportionali, and where he first started to use double entry accounting system. I've been thinking, how can I explain double entry accounting system like in 15 minutes while people study it for 4 years in university and have not succeeded, but I will just show some examples. And you've probably heard that equation, like your debit should be equal to your credit, right? Have you? Yeah, okay. Thank you. Why is that? His idea is that every movement of money from one place to another is actually can be a result of 2 actions, 2 entries, and you have to just write them in your ledger. And since until actually your transactions on one side of his ledger equals to another side, everything is okay. That's the simplest check that you can make with your accounting system. So here is an example. Let's say you are making a purchase of a laptop, and there are 2 columns, like debit and credit, and the laptop costs $2,500, and what you result with is the transaction of your cash to supplier. Like, so you have 2,500 less after this, but you have an asset, which is a laptop, which worth 2,500, and at that moment, everything is okay at your leisure. The more sophisticated example, for example, you would like to lease a car, and you go to a leasing company and say, take a car which costs like $12,000, but you don't have $12,000 at that moment. You only have $2,000, and you pay cash of $2,000, but you also now have a liability to pay $10,000 more, right? So we at least have 3 entries at that moment. The most complex example in this talk. So you are buying an apartment, and you would like to have an apartment which worth of $120,000, right? And you don't want to pay at all when you get it. So at first, your liability is $120,000. And each month, you have your salary, which increase your amount salary account by 10,000, and then you spend them. But you decrease your liabilities for bank, not like 10,000, but only 9,000, and you also pay interest like 1,000. Is it okay? Do you understand that? I can try to explain it again if you need. Okay, nobody cares. Okay. And as you can see, if you summarize everything on the left side and summarize everything on the right side, you will have a same amount. And this shows that your account is balanced and you don't have errors. That's the simple way to check if everything is okay. So why should I care? Is there any way to implement this in Ruby? Of course there is. And there is a gem which is called double entry. It is made by Envata company, like the marketplace. I guess you've heard about that, where they have lots of features. For example, when you move money from one account to another, they have a pessimistic lock on both records so that you cannot double spend or lose money, like subtract something wrong. So this is a good solution. What else can we see here is that there are some kind of events like purchasing a laptop, leasing a car, buying an apartment, which affects our system. And actually, these events can be described by some kind of rules. And like system can know how to write this down in different accounts. So it looks like event sourcing for me, like a pretty common pattern. And finally, we have something in our world, Ruby world, to deal with this event sourcing thing created by Arkansas agency. I don't know why, but they have a Rails-less event store way of using it, but it's still called Rails Event Store. That's almost it. Where to go after this talk? If you would like to learn more about how it works, please visit this link. This guy, actually, he's talking at the ClajureConf, and they're using the Atomic and such kind of cool stuff, where they use it to create an accounting system. But rule number 4, make sure your sheet is balanced. Questions?